This video is for Chapter 8, Section 4, and it is all about the sine and cosine ratio. Prior to this video, we learned about the tangent ratio, which was comparing the opposite side to the adjacent side for an angle in a right triangle. So the sine and cosine ratio are very similar. We're going to be looking at the angle here, 45 degrees, and in this triangle, 45 degrees. Here we'll look at x, and here we'll look at 30. And the sine ratio is going to be when we compare the opposite side of that angle to the hypotenuse. Now remember, the adjacent side is called that because it's not the hypotenuse. The hypotenuse should be obvious every time. So when I say 45 degrees opposite over hypotenuse, the opposite is 5 and the hypotenuse is 5 rad 2. So on this picture here, I can see that the sine of 45 degrees is going to be 5 over 5 radical 2. Now, even though I don't like to have radicals in the denominator, what's most important is when I reduce this, I get 1 over radical 2. If I was to do the same thing for this problem, the sine of 45 degrees, I'm going to end up getting 3 over 3 radical 2. That will reduce, and I get sine of 45 degrees equals 1 over radical 2. So it appears the sine of 45 degrees has a ratio of 1 over radical 2. Remember, we did tangent was 5 over 5, which equaled 1. So the sine has its own ratio. Let's go over and take a look at these problems here. The sine of x for this problem is going to be 3 over 5. The sine of x in the problem below it, so I should change this, I'll call it y, is going to be 6 over 8. Not 8, sorry, 6 over 10, which is 3/5. Opposite hypotenuse. Now, this tells us that x and y are the exact same angle. They have the exact same sine ratio. And we know these triangles are similar, and x equals y. We know that's the same angle. And 3/5 is not 1 over radical 2. Every angle has its own sine value. Now, I could check cosine. The cosine of x is equal to the adjacent side. So now I got to switch this. Now 4 and 5 are both adjacent, but 5 is clearly the hypotenuse. So 4 must be the adjacent, and 5 is the hypotenuse. Go to y, and we have 8 over 10. Again, we know that x equals y. They are the same angle. They have the same sine, 3/5, and they have the same cosine, 4/5. So every angle seems to have its own sine and its own cosine. Here are two more triangles where the sine of 30 in this triangle is equal to the opposite over the hypotenuse, 4 over 8, which is 1/2. In this triangle, the sine of 30 is equal to 5 over 10, which is 1/2. So the sine of 30 is 1/2. We just discovered one. That's one we definitely know. We'll check it on the calculator in just a second. So next we go to cosine of 30 degrees, and that would be adjacent over hypotenuse. So that would be 4 radical 3 over 8. And on this one, the cosine of 30 is going to end up being the adjacent over hypotenuse, 5 rad 3 over 10. Now, 5 and 10 can reduce, and this becomes radical 3 over 2. 4 and 8 can reduce, and this becomes radical 3 over 2. This is all consistent with the work that we've done. The sine ratio is opposite over hypotenuse. The cosine ratio is adjacent over hypotenuse. it's now time to pull out our calculators and start working with this material to see if we can get the values that we are looking for. All right, I've got my calculator. So I'm going to now check a few things. First of all, the sine of 45 degrees. If I take my calculator and put sine 45, I end up with 0.707. If I type in 1 divided by the square root of 2, I get 0.707. So the sine of 45 degrees is 1 over radical 2, 0.707. Now here's one that's a little odd. I have the sine of x equals 3 over 5. What I'm going to do now is say, well, remember we learned that to get x by itself, we use an inverse. So I can actually type into my calculator and say second, let's clear this out, second sine 3 divided by 5, and it will tell me approximately 37 degrees. This is the same value we got in our previous video. So x is approximately 37 degrees. If you were to take the sine of 37, sine 37, I get a number of 0.60. 3 divided by 5 is 0.6. Lastly, I could try sine of 30, in which the answer is supposed to be 1/2. So I can say sine 30 degrees, and I get 0.5, 1/2. Here are some things we can try. Sine of 35. So our calculators, we need to check. So sine 35, and I get a result of 0.5735. So make sure that you are getting an answer of 0.5735. What about cosine of 23? So I have cosine 23 degrees, and my answer is 0.9205. 0.9205. You are just confirming that you're getting the same thing. Now, sine x equals 3/4. To get x by itself and move the sign over, we go to an inverse. For many calculators, you may have to do 3/4 first. For my calculator, I can do second sine 3 divided by 4, and I will get 48.6. So let's make sure we understand this is approximately 48.6 degrees. And all you're doing right now is confirming that you get the same values. I'm now going to set up 2 or 3 problems for us to do to solve with these, and that'll be the rest of the lesson. Okay, here are the 3 examples we need to do. They're going to look very familiar to the tangent examples, so I'm going to try to go pretty quickly and use my calculator to crank these things out. Right triangle, 55-degree angle. I see that I have opposite and hypotenuse. This is a sine problem. Sine 55 degrees equals x over 10. Simple solving move. Multiply by 10 on each side, and I am ready to go to my calculator. I can now take my calculator, and either I can figure out sine of 55 and then multiply by 10, or some calculators I can type in 10 times the sine of 55. And I end up getting 8.19. So I'm going to go ahead and approximate it as approximately 8.2. Example number 1 done. Example number 2. Well, I have an angle, a right angle, but I don't have the opposite side. I have the adjacent side and the hypotenuse. This is a cosine. Cosine 22 degrees equals adjacent over hypotenuse. Now this is like the second example in the other video. I have to multiply by x on both sides. X cosine 22. This is a multiplication. And now I divide by the cosine of 22 degrees. You should be trying to get the same value at home, and then in class talk to me if your calculator is not doing this. On my calculator I can do 8 divided by cosine of 22. and I have to put the 22 in parentheses, I end up getting approximately 8.6. So approximately 8.6. Now that is larger, just not much, but it is the hypotenuse. My final example will be here, number 3, where I have 7 and 10, and I'm trying to find the angle. I could use the Pythagorean theorem to find the third side, but I want to find the angle. Now I have the opposite, and I have the hypotenuse. So this is a sine problem. Sine of x, the angle, equals 7 over 10. Well, this is one of those ones where I already have the sine. I need to find the angle. So I want x to be alone, and in order to move sine to the other side, I have to take the inverse, or I have to do the opposite of the sine. So I go to the calculator, second sine, 7 divided by 10, finish the parentheses, and I've got approximately 44.4. So x is approximately 44.4 degrees. Those are your 3 examples of how to use sine and cosine. We have one example where our variable is in the numerator, one where our variable is in the denominator, and one where our variable was the actual angle measure. That's it for Chapter 8, Section 4. You can now begin working on your sine and cosine problems.